When it comes to building an infrastructure, there's a real spectrum, and serverless is definitely to one side of that. But sometimes, in order to understand something, it also helps to understand what something is not. So let's consider not just serverless, but the whole spectrum of infrastructures that exist. Let's say you want the most control over your infrastructure, maybe for compliance or security reasons. For this, you start with a physical server. You really have full control here. You can select your hardware components and everything on top of that. The virtualization, if any, operating system, data, application, and services. It also means you have responsibility for all of this. Updating, patching, configuration, and fixing it if anything goes horribly wrong. And hey, there is nothing wrong with this infrastructure choice. It's just not always the most effective for the largest amount of people, and requires a lot of capital expenses, components to buy, and time to set things up. Now, maybe you don't have the space or security for a physical server, but you still want a lot of control. This is where virtualized servers sit. The hardware is managed by someone else, and you can create resources such as virtual servers or storage on demand. But you're still in charge of a decent portion of this, from the operating system on up. All cloud providers have infrastructure as a service offerings, such as AWS EC2, Azure Virtual Machines, and Google Compute Engine. Platform as a service obfuscates even more, and you can even argue serverless is a form of platform as a service, taken to its ultimate level. This offers, well, a platform. You won't manage the operating system or below, but data, application code, as well as things like scaling configurations are up to you. With a serverless application, you won't ever think about what network your application is running on, or see a deployed server. With platform as a service, well, you might. And that brings us to function as a service offerings, wherein you are provided a platform to run your functions on demand without having to worry about where it's hosted at all, or its scaling. Although you will have to work within their memory and processing time limits. You pay only when the function runs, and it's generally the backbone of serverless architectures. But it is not the be-all end-all of serverless. It's serverless compute, but you would be remiss not to consider that serverless is about more than compute. You can run serverless containers, serverless databases, serverless data processing. In fact, a lot of cloud offerings we don't usually think of as serverless very much are. You're not hosting a message queue yourself when you use AWS SQS, Azure Queue Storage, or Google Cloud PubSub, are you? So what is serverless good for? Well, a lot. It just might require a little change in thinking. For example, when you're creating a serverless application, you're not going to have it as a service always running on some port. Instead, serverless functions respond to events, and serverless architectures tend to be, well, event-driven. This means a function or a small unit of code, ideally the least amount of code you can write, responds to something that happens called a trigger. Maybe an image gets uploaded or an API call is received. You might have heard the term microservice before, and microservices really lend themselves to serverless architectures for this reason. I mentioned you want the least amount of code possible, right? Where you might have once packaged your authentication with your data querying and processing and its front end in a single monolithic application, with serverless you'll want to break everything down into its component parts, using serverless functions to tie them all together. So you'll have your front end hosted on a serverless container where you log in via an authentication service, and maybe you interact with some API triggers that talk to functions that query or process data. Of course, this does mean moving to serverless is a little more difficult than moving a monolith from a virtual machine to a container. It requires a little more finesse and a little more thought. So, serverless architectures represent a significant shift in how we approach building and managing applications. It's not just about offloading server management, it's about embracing a new mindset that prioritizes agility, scalability, and cost efficiency, albeit at the expense of customization and control. There are countless possibilities and some potential pitfalls with this evolving technology, but it certainly presented a new paradigm in architectural design and application development.